Welcome back everyone, Mike McConville here, Stratford, Ontario, Canada. I have a very special treat for you here today. This is a Michael Gurian, 1977 Michael Gurian. 43 years ago, he had anticipated that this guitar will eventually need a neck reset, and that's exactly what it needs. Now the way he attaches the neck to the body is quite ingenious. When you think about all the different sort of neck joint configurations that have appeared over the years in the industry, Michael Gurian's take on a removable mechanical joint employs two ebony pins. Now I reach in with the side cutters, I've already done it on this side, and just against the head block I kind of loosen that pin off, and this is what we've got. We have a tapered ebony pin, one on each side of the head block. So let me get the other one. There is our other ebony pin. Off of this end we take a little less than a 1/16 of an inch, and to here we go to 0, and what that does is that resets the neck to body angle. So we're buying back that 40 years of string tension. So I take off a minute little bit here, and that will change the neck angle. So I'm just sort of flexing this down and just pull the sandpaper through. A little bit at a time. So what I've done is I've got 400 grit sandpaper that I kind of stick in there, close it up, and pull it through. You need to make sure that you have equal strokes on each side. So I've done basically 5 strokes on each side because you want to make sure that you keep the neck in line. Now I'm going to flip that over and I'm going to check that again. I will need to heat this fingerboard extension up and slip that joint and pull the neck right out, because we're going to have to reposition the holes that receive the dowels. As we see in many acoustic guitar neck joints, the actual fingerboard extension is glued to the surface of the soundboard. But what's interesting in this case is it's a tenon and mortise, which isn't that unusual. But what Michael has done is he has 2 tapered ebony pins, an upper and a lower. So this treble side lower ebony pin pushes through the head block and into the mortise from the treble side of the guitar. On the bass side, there's a corresponding tapered hole in the edge of the head block on the bass side, and this upper pin pushes in from the bass side to lock that tenon in place. No glue. It's a mechanical fit. So here's the challenge. As you saw earlier in the video, I had adjusted those inside cheeks to set the neck angle back a little bit to buy back some real estate from all those years of string tension. And that's pretty typical. But the challenge now is these tapered holes are not going to correspond anymore to the tapered holes in the block. So these holes need to be filled, drilled undersized, and then reamed to fit those pins in order for that same mechanical function to pin the lower portion of the heel in tight against the sides. And I have to say that after doing this type of work for a half a century, when you're in the zone like this and everything's going right, you gotta know enough to hang back for that second operation. And this is definitely the case here, because what we're doing is we're obviously repositioning these holes, but in the process of doing that, this end grain here is super weak. So I'm not going to try to do everything at once. So you have to keep in mind that this is long before the advent of CNC machines. All of this was done by hand. I'm kind of bound and determined to respect the original builder's intent with this mechanical neck joint with those ebony pins. I think it's a great idea. And I'm proceeding with caution here because you can see the grain runs out on the outside diameter of that dowel. So I'm going to let that set overnight, and then I'll come back and basically repeat as above. This is a stacked truss rod. This rod here that's closest to the fingerboard, it goes into a stop hole in this block. So when you tighten the bottom rod, that's obviously threaded, when you tighten that up, what happens is this rod here is forced into a convex shape, and that's how it works. These were actually pretty common back in the 70s. Now, of course, the two-way truss rod is a completely different thing, and we will definitely discuss that in another video. So we're going to take a break on this one. We'll come back tomorrow and drill and fill that other hole. Before I go any further with this restoration, there's some points that I need to clarify. I really want to kind of spell out all the thought processes that I made to do this neck reset on this pinned neck joint. We through drilled that hole, filled it in with a maple dowel. We're about to do the same here. I've got the hide glue heating up there. I'm going to glue a mahogany cross grain strap onto the face of that tenon. This is the weakest point here. Before I drill that hole, I'm going to glue that strap on. Now I do want to take you over to the actual head block itself. So this is obviously the mortise and the head block, and you can see where the pins come through. I did up a fairly detailed drawing to kind of explain this even better, but I'll start with this. That upper ebony pin comes through the edge of the head block inside. These are through drilled holes, but they're tapered. The lower pin comes in from the treble side. I think the drawing will help to clarify what we're doing, how we're doing it, and why I'm doing it the way I'm doing it. So I thought this drawing may help to clarify things. I just drew this up on a piece of scrap bristle board. This surface here is the surface that glues to the rosewood back, and of course this is the top surface that glues to the soundboard. This, as you can see, is the recess or mortise in the head block. This pin is fed in from the outside edge of the head block. The actual mortise itself is 3/4 of an inch wide, and then you've got 7/8 of an inch of mahogany on either side. So I've done up this drawing specifically for my Patreon subscribers, the builders and techs. If you're considering tackling this version of a neck to body joint, which I think it's timeless. I think it's a great idea. Anyway, so you got your dimensions. So your overall width, 2.5 inches. Overall height is 4 inches. And your overall depth is 1 5/8. You've got a 3/4 inch mortise and then 7/8 of an inch of meat on either side of that mortise, and of course these tapered pins. Well, we've got our hide glue heated up and we're ready to put on this mahogany strap. So this can be a bit of a challenge to get some clamping pressure on this. Here is how we do it. One guess what this is. One more hockey puck trick. I did taper the edges back on that because I don't want it to be proud of the actual tenon. So we're going to let that set, and then we'll be ready to through drill the other hole without any danger of splitting the tenon and insert that other maple dowel in preparation for the new placement of the tapered holes for the tapered ebony pins. It's important to know that it is really just the shoulder of that lower pin and the shoulder of that upper pin that hold the lower portion of the heel tight to the body. It is a press fit. So those holes that we filled and will re-drill and taper, we got to be very careful and very exacting on the placement. A little bit more reconnaissance. Have a look at this. So the total protrusion of that pin, it's about 3/8 of an inch. So when I ream that tapered hole for the repositioned holes in the tenon, I got to keep that in mind. We're only going 3/8 of an inch deep. So just so you can understand where we're going with this, I'm going to cut this a little bit shy of that line. I'm going to kiss that flush with a disc sander. Now back to the tapered pin. So what you're looking at here is my storyboard. That's going to tell me how deep I need to ream the new holes that we put in that tenon to get a perfect fit. So we want to have about 3/8 of an inch of protrusion. And you can see at the very tip, that's actually shaved or sharpened like a pencil. Before I go to the next few steps, I need to explain something about the neck to body angle. There are 6 different planes that need to be correct on this neck to body angle. The neck needs to be correct this way and this way. It needs to be correct this way or this way, and it needs to be correct this way or this way. 40 years plus of string pull has kind of pulled the neck up like this. So we've taken the neck off, and the main angle that we're after and that we have reset successfully, I'm going to show you in a second, is this angle here. We've tilted the neck back. So when I set that straight edge on the frets and I slip up to the bridge, it should just kiss the top of the bridge, just like that. That is the perfect neck to body angle. So that's going to leave us lots of room on the saddle for many years to come to be able to adjust the action with any gauge of string anywhere the customer chooses. I actually prefer to use the XLT when I'm at this stage of the neck reset. In this temporary setup, as we check to make sure all of those 6 angles I just discussed are perfect, this is how I set up. The neck is held in place with a canvas strap on the pivoting V-block. I've got this heavy-duty rubber band that you've seen me use in other videos and a piece of hockey puck. Now that is tensioned to pull the tip of the heel in tight, and that's what sets the neck angle this way. I've got this quick grip clamp to hold the fingerboard at the neck to body junction tight down to the soundboard. Lastly, I have this paper clip that's holding the very tip of the fingerboard down tight to the soundboard as well. So I've checked all of those angles that we just previously discussed. Now what I'm doing is I'm reaching into that tapered hole. I've actually tapered this pencil so I've got a perfect press fit so that when I mark that dowel, I'm going to get it on dead center. I'll reach in first to the upper dowel, which comes in from the base side of the head block. I've got this just long enough to mark our center for the new location of those tapered pins. So I'm just getting the treble side now. Be careful that nothing shifts while I do this. Now we'll take it apart and have a look. So that's our new center for the lower pin, and that is our new center for the upper pin. 2 things I love about this setup with the new drill press Number one, it's on an air switch. Number two, I've got that laser guided centering light. Whew, for a job like this, super critical. Here we go, showtime at last. There's our bass side pin. Our treble side pin. Tap those into place. I have a piece of lead puck for babbitt bearings. Yeah, you can see that pulling right tight when I tap that pin in. That's a good sign. So this is the setup for the fingerboard extension. So I got my scoop up sticks here. We've given that a couple of minutes to sort of set. And use my dry sticks first just to get the lion's share of the wet glue. And I've got 2 wet cloths, or slightly damp cloths, and 2 dry cloths. So here's our first wet cloth, just to kind of clean up every trace. So we just wipe that up, no trace of glue. Other side, same thing here. I'm going to just pull that off so we can get across the end of the fingerboard as well. Take those clips off for a second. Get our dry stick. Here's our wet wipe. That's it. We just basically dry up all the evidence. Now we're just going to go across the end of the fingerboard here and get that little bit of squeeze out. Got another wet cloth here just to clean that right up. Other side. Put our clips back on. Well, you can see a little bit of squeeze when I put that on there. Good. So we've gotten every trace of glue squeeze. Okay, that neck is back on. We'll let that set overnight, and now we can get on with the rest of the job. So what we have here is the original pick guard that basically fell off. Whatever adhesive was used way back then, 40 odd years ago, basically dried out and crumbled to dust. I have this 3M peel and stick adhesive on the back. Before I go to attempt to locate to the proper position, I got that masking tape on there, took a straight edge, drew a line over here, took a straight edge, drew another line, and I've basically got to line those 2 lines up, and it touches the edge of the fingerboard. These pieces of tape were basically used just to hold it in place while I made my little cheater marks there. So I think we're pretty well ready to go now. We're kind of on the home stretch. I just left it off for the majority of the job because there really wasn't any need for it. That's what I've got. This is an ultra thin adhesive. I actually got this from one of my students who's an engineer at 3M. I got a roll of that stuff. Boy, I don't know, it was many years ago. So we just kind of peel. Yeah, this stuff definitely is not going to come off. So we just line that up. Got my tip down and line this arrow up. And that's it. Well, customer doesn't have to worry about this coming off now. At least not in our lifetime. There you go. Little trick to locating your original pick guard to its original position. We have removed the original nut and just getting ready to do the compensated nut blank. So I'd actually edge dressed that while the neck was off. I still have to smooth it out, but it's flush. They were protruding out a little bit. The wood has dried out for 40 years, so you could start to feel them. There was a bit of an edge. So I'm going to continue right at the neck junction. I could see that there's a little bit of discrepancy there, and that also is normal. You're doing that reset. That's looking good. Just check up the top here. Yeah. No. Looking good. Okay, we're ready to recrown. Put our cloth back 400 just to take out any edginess. So I do a clockwise circular motion, and that basically gets this side of the fret. And then I come back counterclockwise to get the other side of the fret. Once that's done, then I go full length like this. A little trickier working that part over the body. I kind of wipe this way and then wipe the other way. This is cloth back, that's why it's not tearing. Kind of pulling, and that flexible material on the scrub block actually distorts and smooths out all those edges. Now we can go along the length. This is still 400 we got here. So that 400 cloth back basically takes all the barbs out. So when we switch to the 600, it's not going to tear the paper. 600. Load this canvas wheel up at Jeweler's Roost. That last fret. Much better. This is what we ended up with the original saddle. The low E and low A, there was enough on the saddle to intonate them perfectly. What I'm referring to here is fretting the 7th fret note and then fretting the 19th fret corresponding octave note on the same string. These were the only 2 strings out of 6 that intonated. The D string and the G were 8 cents flat, and they were right to the leading edge. So we definitely need to make a cantilevered saddle to get this to line up perfectly. The B was 2 cents sharp, and there was a little bit of room for that to go back, so I think we're going to be okay with this footprint. So I'll get out the bridge slotting jig. So I'm going to just widen the saddle to the full 1/8 inch, and that'll give us a little bit more to play with as far as the B string, bringing it back that little bit. The high E string was 4 cents flat, and again, it was right at the front of the saddle. We are going to have to cantilever to get this to line up. I've got this bridge slotting jig set up, and I have my Bosch Colt sort of indexing plate. I've already lined it up with the existing slot, and like all the accessories, the disc assembly for your drill press, the XLT, and the GPS workstations, all of these tools are engineered for you to flip the purchase price in 1 or 2 jobs at the most. So I'll bring you in for the cut. So this indexing plate that comes with your bridge slotting jig is a CNC duplicate of the Bosch Colt router base. So the indexing pin basically takes all of the guesswork out long before you flip the switch on the router. I know exactly where the cut starts, where it ends, and its trajectory. I actually loosened off the rails and then retightened them just to give us that little bit of extra play. So this is actually wider than 1/8 of an inch. I made the cut tight to this side. When I got to the stop, I moved over. You can see it's about 20 thou. I moved over, came back. So this will give us lots of room to line up the intonation all the way across. We've widened the slot front and back. Nothing quite like the smell of Brazilian rosewood. On with the cantilevered saddle. No clamps. Everything is finger tightened. These rubber riser blocks come with the bridge slotting kit. This is why I leave them in that long stick form, so they can be used for nuts or saddles. So the first thing we're doing is basically fitting that thickness of the leg so that it drops into that slot. So the next step, I'm just skimming it down fit that slot. The blank is slightly longer than we need. Now I'm rounding off the ends to that line, the right length that we need, so that it drops right into that slot. Back to the guitar. Oh yeah, that's the fit we're after. With a drill press disc sander assembly, I'm just going to kiss the underside of that cantilevered ledge to match the curvature of the crown of the rosewood bridge. I got a tracing off that original saddle, trace that onto the crown of our compensated cantilevered saddle. So we'll shape that next. So the calculations are based on the tuning discrepancies from the original saddle. So the low E was basically in the center of the original slot, and it was perfectly in tune. We're talking about the 7th fret fretted note and its corresponding 19th fret octave. A string, same thing. So I'm just putting those right back where they were. The D string was 8 cents flat, so it obviously needed to cantilever and go beyond the confines of the original slot. So I've marked that here. Same with the G, moved that forward. The B was actually 2 cents sharp, so there was lots of room to sort of go back. And now that we've widened that saddle slightly, we'll have no problem intonating this 100%. And finally, the first string was 4 cents flat, and it had come right to the edge of the original bridge slot. So again, we're going to have plenty to play with. I have crowned that blank to match the fingerboard radius. So the next step now is to cut these values. Now that we're on the home stretch with this Gurian guitar, I also have this HD28 that we're going to be working on, and I thought I would take the opportunity to sort of make some comparisons here. So let's start with the width and taper of the fingerboard. So at the 14th fret, where the neck meets the body, the fingerboard width on the HD28 is 1 11/16. So the string spacing from the 6th string to the 1st string at the bridge is 2 1/8 of an inch. The spacing at the nut is your typical Martin spacing, which is 1 11/16. So let's have a look at the Gurian. The fingerboard width on the 14th fret of the Gurian is 1 15/16, so it's a slightly less than 2 inches. Now the string spacing at the bridge for the Gurian is 2 1/4 inches, so it's actually a wider string spacing than the Martin. And the string spacing at the nut on the Gurian is also narrower than the Martin. It's 1 5/8. This narrower fingerboard with a wider string spacing just means that you've got to be that much more exact to get those 6 angles we talked about. Boy, there is not a lot of forgiveness. Look at how close the strings are to the edge of the fingerboard. Okay, over to the Martin. So with the Martin, there's definitely more space from the edge of the fingerboard to the edge of the outside diameter of the string on both sides. And again, at that neck to body junction, that's pretty generous. There's lots of room on that outside. So in summary, the precision of the neck reset on the Gurian guitar needs to be even more exacting. Very happy with what we've got. Let's go in the house and have a listen. This is a special footnote for my Tier 3 Patreon guys. I want to drop that action down, not much, but a little bit. After all the work we've done, the intonation is perfect, all the contact points all the way across are perfect, and the radius matches the fingerboard perfectly. When you get to this stage of the game, if you want to drop the action down, it's got to be taken off the underside of the ledge and then the underside of the actual leg that goes into the slot. And that is exactly what we're about to do. So before I pull that saddle out of the bridge, I want to drag that pencil lead across the crown so that we establish exactly where the intonation is for each string. Now you got to remember that we are going to be dropping the action down, which means a lot of these notes that were perfectly in tune may end up actually being slightly flat because you're exerting less pressure to pull the string in contact with the fret. Okay, I'll slip over to the disc sander. I've got a good idea how much I want to bring that down, so I'm going to scribe that saddle first. I'm going to start there. Other side, same thing. This I'm going to take down to the line on my stationary disc sander. I will need to take that ledge down the same amount Basically taking that line off all the way across. Back to the guitar. I wanted to make sure I had the right camera angle to bring you in for this, but on the edge of the disc, I'm paring that back to the pencil line. So that's what we end up with now. Okay, let's check the action and intonation on the guitar now. Well, in the final analysis, this is what we have. So before I take it into the studio and really let you hear this thing, chord to chord, fret to fret, note to note, thought I would just bring you in close and let you see where we ended up as far as that saddle goes. So the Martin on the outside tip is 128, and the Gurian tapers down to 106. Interesting observation. This is the final call on the nut. These are EJ16 D'Addarios 12 to 53 at concert pitch. Let's have a look at the other side. And there is the view from the bass side. Let's go have a listen. Oh, and one last thing. I feel like Columbo, big fan of Michael Gurian. This is his Gurian Workshop Earth, third planet from the sun label. Well, this amazing Gurian guitar is finally done, tweaked to the nines. This is what we ended up with at the bridge. I've got those 3 sets of strings out because I went through 3 sets of strings to determine the best string for playability and tonal response on this guitar. I started out with the bluegrass strings, the EJ19s. I had mentioned this to the customer, we'll try the bluegrass strings, and we did, but it just wasn't working. The guitar was choking, and I ended up dropping down to regular light strings, and it was much better. But it wasn't until I put on the custom light strings that this guitar just opened up like a book. You're going to hear it. I'll bring it in the house, and it intonates incredibly, perfectly in tune now. So these are the final values on that cantilevered bridge saddle. It's really just the first, the third, and the fourth string that are cantilevered past the original slot. And this is what we got at the nut. I ended up settling on the EJ26, which is a custom light. They're not extra light. They're 11 to 52 as opposed to 12 to 53. Now, mind you, I did I know I'm just mother henning this thing to death, but I did end up stepping up that first string to a 12. So it's this EJ26 11 to 52 strings, and I stepped up that first string to 12th thou from 11th thou. But wait till you hear this. This is a tremendous sounding guitar. It's interesting that he used a Brazilian rosewood bridge. I could smell it when I routed it. And East Indian rosewood back and sides, ebony fingerboard, and then the Brazilian rosewood overlay on the headstock. Kind of interesting mix of woods. With the neck reset completed, that is the fit of the heel to the sides on the bass side, and there's the fit on the treble side.